Good morning. You're welcome to my channel. My name is Jane Bio, your regular biologist. I'm so excited to be here. If this is your first time, you're welcome. I did the first video, the section A, which has to do with specimen E to D. And this is the second section, which has to do with E, F, G, H, and G. You're welcome. The last video I did, someone corrected me and said that the phylum name for weevil is Arthropoda. You know, the R is silent. And the person said that I said from my pronunciation, it was Anthropod from my pronunciation, but the real pronunciation is arthropoda. Remember that the R is silent, so there's no way you can hear it, but you heard an. It is not an. The right pronunciation for the phylum name of the bean weevil is arthropoda. I believe it's clear enough. Spelling Arthropoda. I believe that's clear. So today we're looking at specimen E, F, G, H, and J produce a longitudinal section of the pineapple fruit. Now we'll be asked, what's the full classification of the pineapple fruit? The answer is multiple false fleshy fruit. For orange, the full classification is simple true fleshy fruit. What's the type of fruit of pineapple and the type of fruit of orange? Pineapple is multiple berries, because if you look at the pineapple fruit, it is a mixture of many fruitlets. That's what you're seeing on the pineapple. That circles, they are the multiple fruitlets. So now the type of fruit for orange is berry. One characteristic feature of the pineapple fruit, the answer is presence of the crown of leaf. Now other fruit that could be likened or that are in the same family, or other examples of fruit that are multiple fruits like the pineapple, answer is breadfruit, whistling pine, and jackfruit. What is the reason for classification? I should have said it earlier. What's the reason for classifying pineapple as a false fruit? The reason is because it's a fruit that is formed from multiple flowers, or a fruit from an inflorescent flower. Then for the orange, that's the reason for classifying orange as a simple true fruit. Reason, it's a flower, is a fruit that is gotten from a fertilized ovary. The life cycle of the pineapple fruit, it is biennial or perennial. That's 2 years or 3 years. Two of them are correct from my findings. Then the life cycle of the orange fruit is perennial. You know, we've cut the longitudinal section of the pineapple and the transverse section of the orange. Now, key four observable features of the pineapple and the orange. I'll be giving more than four. Number one, presence of inflorescent stalk for the pineapple, absence of inflorescent stalk for the orange. Pineapple is a large fruit, orange is a small fruit. Three, the orange, the seeds are not attached to the skin. Let's say they are, when I say removable, the seeds, presence of seeds. While for the pineapple fruit, no seeds, rather seeds are attached to the skin. For the pineapple, presence of spines. Orange, no spines. Then I went on to write here for the orange, presence of oil glands. Pineapple, no oil glands. For the, I'll go again with their shapes. For the pineapple, it is oval in shape, while the orange is round in shape. Now, this is just what we can see. If you're going to draw, I feel, in my understanding, that you must show some certain things in your diagram for the orange and for the pineapple. Now, let's start with the pineapple. You will draw the crown of the leaf first. Crown of leaves must be shown. I think that is one of the things that will score us one. Because normally when we mark, it's always one, 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 like that. The title of the drawing should be shown. The title should be Drawing of Specimen E, or Drawing or Diagram of a Pineapple Fruit. Either you give it that name or you just say Drawing or Diagram of Specimen E. Now, you must also show the magnification. The unit is not necessary. Just go ahead and show times 0.3. From what I did, I got times 0.3. Then you must also show the inflorescent stalk that runs from the crown down. It must be shown. And then it must show the peduncle down, because it's just like the fruit stalk. The fruit stalk, it must show the fruit stalk, which is the peduncle. Then you must show the seeds by the side. There must be seeds attached by the side. One or two seeds must be shown. And then you must show the spikes. Will I call it spines? That bracts, those things that come on the sides. It must be shown. Now for the orange fruit, by the time we've drawn a large spherical circle, we must show two lines showing the epicap. In the middle, you show the placenta. Then you show us the mesocarp must be shown, the endocarp must be shown, and the succulent hairs must be shown. I think this is what can score us a full mark than having observable similarities between specimen E and F. Both have scars, presence of scars. Oh, just use the word both. Both has scars. A fruit has two scars. One scar is the one that attaches to the style, remain of the style. And the second scar is the one that attaches the fruit to the stem or to the receptacle. So both has scars. Both are attractive in color. 3, both are edible fruit. 4, both are fleshy fruit. Then 5, both possess seeds. I believe with this we are good to go. Then we're now going to the specimen G and J. Now for that water, which is H, 3 ml of water, I reasoned that if we're going to use that specimen or it will remain absent, if we're going to use it, I believe we might use it in preparation of the B Waec test. When I checked 2011 WAEC, I noticed that they used a carrot, they crushed a carrot and used it as a sample in place of this raw egg. Now, it was used as a brewery test. How was it done? Some samples of the carrot was introduced it was crushed with water and introduced, maybe the liquid was introduced in a test tube. And then the first thing that was added was few drops of sodium hydroxide. You can go back to that year, 2011. Then the second thing, when you drop the sodium hydroxide, you shake, because sodium hydroxide does not mix well with the mixture, you shake. Once you shake, you now in that year they added 1 ml of water and shake. Then the third thing that was added in drops, little drops, was copper 2 sulfate. And the results showed absence of protein because it did not turn purple. Now, for this experiment, since we're using the raw egg, I feel or I think, I might not be totally correct, that we will add first, once we use the syringe to puncture the raw egg on top, we draw out a little of the egg white, introduce it into the test tube. The first thing we'll be adding will be sodium hydroxide. Then you shake it very well. Then we will add that 3 ml of water. 3 ml of water. You use a measuring cylinder. You add and you shake. I've done this experiment, but I keep repeating it because I'm not really so clear on what Waec wants to use that water for. But I did that experiment. So by the time I added the 3 ml of water, shake. The thing was lighter. The color was light, no color change. Then I added few drops of copper 2 sulfate. Immediately I added the first drop. The color changed to deep blue. You can try it. You can try it. The color changed to deep blue. Then, as I continued shaking, it turned purple, showing presence of protein. So that's that. I don't want this video to be too long. Now let's go to the last one, which is G and J. G and J. That's the fresh egg and the boiled egg. I believe that egg now, after we've punctured it, they might ask us to break it and put it on a petri dish and compare it with this boiled egg. Now this boiled egg, I boiled it after I allowed it to cool. I just used my knife and scrape it. You can see that the edges are rough edges. So immediately I scraped it, it just went off. So I ate the other half, and this is one of the half. Now, if we're given this in the exam, and then the other one, you can say, what's the observable feature of this specimen? Apart from drawing it, of course, we can all draw it. The shape is oval, you draw, and then you label. And then we might be asked to give the function of any of the label parts. Number one is the shell. It gives, sorry, let's not use the word gives. Just go ahead and say for protection against mechanical injury to prevent desiccation. Then the shell membrane, which is this one, the second layer, it allows gases to permeate into egg, into the internal parts of the egg. Then the function of the egg whites. The egg whites, sorry, the word is albumin. The function of the albumin. The albumin, it's a source of water to the embryo. Then the yolk is a source of food to the embryo. If you look at it now, that is all our labeling. Now you can give it to us and see what's the observable feature. Presence of shell. Number two, albumin is chalk white. Number three, the yolk is yellow. Now, if we're to compare observable difference between the boiled egg and the raw egg, which has been broken and poured inside a petri dish, you will notice that the albumin is chalk white, but for the raw egg, it is transparent white. Yes. Then the yolk is yellow, but that one is should be deep. What's the color? Tell us. Deep. If you have stayed to this time, you've watched this video to this end, please just go ahead and hit the like button, subscribe to my channel to just help someone out there and to make the algorithm know that you appreciate this video. I remain your host, Jane Bayo. Thank you so much for staying tuned. Thank you for watching. I love you so much. And to those who subscribed to my section A, thank you and God bless. And I'll be waiting for more subscriptions. God bless you.